Good morning, children. Namaste. So, after a long gap, again I have started to give the explanation over the video. Now, just we have been discussing the metals and non-metals chapter, right? So, what are the topics so far we discussed? Can you recollect? The physical properties of metals. Physical properties of metals. What are the properties we have seen? First, we have seen metals are lustrous and they are hard, malleable, ductile, sonorous, good conductors of heat and electricity. Don't we? We have seen all those properties. Next also we have seen that non-metals generally do not show all these properties. And after that we have seen some exemptions, such as all metals are having the high melting points and boiling points. If you have taken the iron takes very huge amount of heat to get melt. Melting point of iron is very high. But some metals are there, even they put on a palm, they'll get melt. Gallium and cesium. Gallium and cesium, they'll get melt when they are in our hands. And iodine is a non-metal, but it lustrous, shines. And we have seen that metals are very hard, but if you have taken the diamond is electro of a carbon. Diamond is the hardest substance. And most non-metals are bad conductors of electricity, but graphite, electro of a carbon, good conductor of electricity. And we have seen most of the metals are very hard, but alkali metals, lithium, sodium, potassium, they can cut with the knife also. So some exemptions we have seen. And also we have seen metallic oxides are basic in nature, non-metallic oxides are acidic in nature. This is what so far we have covered in the previous classes. And we are going to see from now onwards chemical properties of metals and non-metals. How do they react with oxygen, water, acids? And related to that, some extra points we are going to discuss. Today's topic is chemical reactions of metals with oxygen. Generally we call air, means most of air means burning in the air means mostly that is nothing but oxygen. Air means maximum part is oxygen. So when magnesium burnt, Diwali crackers we have seen in our childhood, no? We get the dazzling light and we get the ash that is nothing but magnesium oxide powder. This magnesium oxide, when you dissolve in water and keep the litmus test, you will find that magnesium hydroxide or solution of magnesium oxide is basic in nature. So like that, now let us see one activity 3.9. Take metals such as copper, aluminium, zinc, lead and all those things, and you try to burn all the lead or heat it or make them to react with oxygen. Try to burn it. Observe what happens. Will all the metals react in the same manner? The answer is no. But most of the metals react. A common statement we can give for metals. When metals reacts with oxygen, gives metal oxide. Remember, metals reacts with oxygen, gives metal oxide. Let us see one example. Copper, when you heat it, when you burn it, it will not burn, but forms a black oxide layer, black colored copper oxide, Cu2O. When CuO, but while writing the statement you have to write copper in brackets 2 oxide. Brackets 2 means its valence is 2. Copper oxide, black colored copper oxide. Aluminium plus oxygen, aluminium oxide, Al plus O2 gives rise to Al2O3, aluminium oxide. So you can see that when metal reacts with oxygen, what we are getting? Metal oxide. Now Al2O3, it is very important to write the formulas. Copper oxide we wrote as CuO, but aluminium oxide we are writing as Al2O3. What's in this? Try to recollect your 9th standard crisscross method, right, to write the formulas. To write the formulas, it is very important to know the valences. Crisscross method. Aluminium valence is 3, just write its valency below the aluminium. Oxygen valency is 2, write the valency below the oxygen, make it cross. Take the oxygen valency to aluminium Al2, because this 2 has come of oxygens, and aluminium valency is 3. Take this 3 to the oxygen, cross O3. Why 3 has come? Because it's aluminium's valency. That's why the formula has come Al2O3. Copper oxide, I am calling it as copper bracket 2, means here with this, for this copper we are taking the valency of copper is 2. Copper valence is 2, oxygen valence is 2. When both the valences are same, you can write the elements as it is, CuO. Copper oxide formula is CuO. So basing on the valencies, we need to write the formula. Now you have written aluminum oxide formula Al2O3. Now we have learned the first topic today. What is that? When metals react with oxygen, they give metal oxides. Got it? And next we are going to the second topic. We have seen the most metallic oxides are basic in nature. What does the basic in nature mean? Basic means when you have taken that solution, put the red litmus paper in it. If red litmus paper turn to blue, that solution is basic. Whatever the metallic oxides we have seen, that we have made a solution, metallic oxide solutions, and I tried with red litmus paper and it turned blue. So I have come to know that metallic oxides are basic in nature. Most metallic oxides are basic in nature. Now that's the first point. Second point, neutralization. Acids plus base gives rise to salt and water. Acidity means this acidity. How can I solve? I need to take the balance to neutralize the acidity. What is that? Eno or some related, which is a base. When base I have taken, the base and acid neutralizes. So acid plus base gives rise to neutralization reaction. Now just now we have seen when acid reacts with base, in the place of base if I take metal oxide, can I get salt water? Yes, salt and water. Why? Because metal oxide is basic. Got it now? When acid plus metal oxide definitely gives the salt and water. And now we will check with one oxide, aluminum oxide. Al2O3 plus HCl gives rise to AlCl3 plus H2O. Balance it later. Aluminum chloride is a salt. Why we got HCl is an acid and aluminum oxide is base. Acid plus base gives rise to salt and water. Aluminum oxide has clearly shown the basic properties. Now I am checking whether it reacts with any base or not. I have taken the NaOH. Al2O3 plus NaOH, base. Aluminum oxide, just now we have seen it's shown the basic nature. Base plus base, with any reaction occurs? Answer should be no, but surprisingly here answer is yes. Reaction occurred. The basic general property of metals means such as magnesium oxide, calcium oxide, all these are basic in nature. Aluminum oxide also we thought it is base, but it reacted with base now and gives salt and water. Sodium aluminum oxide, NaAlO2, it gives salt and water. It means base plus, as it gives salt and water, now Al2O3, how it behave? It behave like an acid. Al2O3 have shown the acidic property now. When it reacted with the bases given salt and water. It means some metallic oxides are there. They show both acidic properties and basic properties. Such metallic oxides we called as amphoteric oxides. What are amphoteric oxides? Amphoteric oxides show both acidic nature and basic nature. Best example, as we have seen now, what? Aluminum oxide is amphoteric oxide. Why? Because it is showing that both acidic property and basic property. It reacts with acids as well as the base also gives salt and water. Got it now? Now we have learned the second topic. What? Amphoteric oxides. What are amphoteric oxides? which show the acidic property and basic property. Example, aluminum oxide. So equations are very important, and that equations also you need to balance it. Okay, need to try. Now let us come to the third one. Will the metallic oxides dissolve in water? Most metallic oxide does not dissolve in water, but some metallic oxide dissolve in water. Whichever metallic oxide dissolves in water, we call them as alkalis. When bases dissolved in water, we call them as alkalis. Alkalis means acid bases can be dissolved in water. Now see, sodium oxide Na2O, will it dissolve in water in H2O? Yes. Potassium oxide K2O, will it dissolve in water? Yes. Sodium oxide, potassium oxide dissolves in water, gives their respective hydroxides. So whichever oxygens dissolves in water, we call them as alkali. Now whatever we have seen, metals are reacting with oxygen. Do all the metals are reacting in the same manner? The answer is no. Some are reacting fast, some are reacting slow. So now third point, what we have learned, what are alkalis? Alkalis are the bases which are dissolved in water. Now we are going to the fourth point. Will all the metals are reacting in the same manner? No. If you have taken the sodium and potassium, they are very quick in air. They react very fastly with oxygen. Even sometimes explodes also. Accidental fights also occurs. Yes. Now what is the best way to preserve the sodium and potassium? Is it good to keep here in the air? No. We need to preserve in such a manner that there should not be any accidents and no reaction should occur. So sodium and potassium are preserved in kerosene. Sodium and potassium are preserved in kerosene. Can you guess why? Because in order to avoid the fire accidents. Sodium and potassium are very fast and they react very fast with oxygen. Now some reactions, magnesium, aluminium, zinc, lead, they do not react like sodium and potassium. They react. But what happens? No, they forms the layer on them, and this layer protects, even prevents further oxidation. That layer stops for further oxidation. Yes, do you remember the first chapter, first text bed? Why do we have to rub the magnesium ribbon? Because magnesium ribbon forms an oxide layer on it that prevents them further oxidation and prevents it from burning also. That's why we need to rub it with the sandpaper. Remember? Got it? Good. Now, even aluminium also forms the layer over it. A thin layer. That prevents the aluminium for further corrosion. But if that layer, if I made it very thicker, that aluminium vessels and aluminium basins and all those things, they can stay for longer time. Now that is the process called anodizing. Okay, Nana? Now next we are going to see the anodizing. But what is the topic we have seen now? Will all the metals react in the same manner? Answer is no. Sodium and potassium are preserved in kerosene because they are very fast reacts with oxygen. And next, some of the metals forms the layers on the and iron. One thing, iron as a whole it won't react, but if you take the iron fillings, if you sprinkle on the fire, all the iron fillings burns very quickly. So all the metals are not reacting in the same manner. Now we are going to see the anodizing. What is anodizing? Formation of a thick layer of oxygen, oxide layer on aluminium. How we do this thing? Yes, electrolysis method. Take a solution, dip cathode and anode, allow the reaction. The one which is connected to positive terminal of the battery is anode, another one is cathode. Now you have to take the pure aluminium as anode. Pure aluminium, you put whichever you want to do anodize, you keep it as an anode. Take the sulfuric acid as a solution, electrolyte. Start the reaction. Oxygen bubbles comes nearer to the anode, reacts with the aluminium foil, forms a very thick layer on aluminium. So very thick layer. So it almost prevents the aluminium to get corrode, rust, spoil. Now that aluminium lasts for longer time. As it is thick layer, even you can paint it to make it more attractive. Got it? So what is the topic we learned now? Anodizing. Now, what are the topics so far we learned in this topic is we have learned chemical reactions of metals with oxygen. First, what did we learn? Metals plus oxygen gives metallic oxide. We learn next amphoteric oxides, aluminum oxide. Such some oxides show both acidic and basic properties. And we learn alkalis. Which bases dissolves in water are called alkalis. Sodium hydroxide, sodium oxide and potassium oxide are alkalis. And next, all metals are not reacting in the same manner. Some metals, when get oxidized, that oxide layers are forming on it and they are preventing for further oxidization. Now we have seen iron as a whole does not burn. Iron fillings can easily, iron when you sprinkle, that burns very dazzlingly. Next, silver and gold does not react with oxygen. And last we have seen anodizing. Anodizing is formation of thick layer of oxygen on aluminium foil. Okay, Nana, thank you, and I'm going to send some questions to you. Please complete those questions, and in the next class we are going to see how do the metals reacts with water and acids. Thank you very much.